Hello, dear students. So, today we are going to discuss a very important topic which is about data normality. Data normality is very important because it is one of the basic assumptions of many statistical models. Normality is actually about looking at the shape or distribution of the data, that whether there exist any outliers in the data or not. So, there are many ways to find out whether the data is normal or not. In other words, we can say that there are many ways to find out whether there are any abnormal or outlier in the data. One way to do this is we can do it with the help of moments. So in order to calculate or in order to find outliers in a data, let's take an example. For example, we have a data listed in column B. So this is our data. Now I want to check. So for finding outliers in the data, first of all we need our data. So our data is listed in column B, and then we need to calculate the four quartiles, like first quartile, second quartile, third quartile, and fourth quartile. We also need to estimate the minimum value in our data. So in order to calculate these five values, the minimum, first, second, third quartile, and maximum values, we can use the function quartile dot inc. So here you have to write quartile is equal to quartile dot inc, and then in the range section you have to select your data, and for the minimum, after the comma put 0. So it will give you the minimum value in our data. For calculating the first quartile, again type the function quartile dot inc, then select your data like this. Let me do it. So when I write quartile inc, then you have to select your data, which is this one, and then put comma and then put 1. So this will give us our first quartile, but you have to fix the values here. So in order to fix the values, just put dollar sign here, and we are set to go. So for second quartile, again write the function quartile dot inc, and then select your range of data and then put 2. For third quartile, repeat the same process, but this time after comma you have to put 3. And for maximum value, again put the function quartile dot inc, then select your range, and after the comma select 4. So once you have these five values, then the second step is that we have to estimate the interquartile range, and interquartile range is equal to third quarter minus first quarter. So what you have to do here is that just type your formula is equal to, and then select your third quartile minus your first quartile. So it will give you interquartile range. So the third step is, now we have to estimate the upper bound and lower bound in our data. So for upper bound, we have to add the value of third quartile to our interquartile range, and for the lower bound, add subtract the interquartile range value from the first quartile. So for upper bound, just put your formula is equal to, and then the third quartile plus multiplied by the interquartile range. And for lower quartile, what you have to do is like select the first quartile and then multiply it by so you have to select first quartile, then minus multiply lower quartile multiplied by 1.5. So it will give you the values of lower quartile. So once you have these values, then the last step is to find out the outlier in the data. So choose a column close to the data, and then select any cell and write a formula. You can use a function or function or, and then you have to select your value. So like this, when so you write your function r, and then in the bracket you have to select your first value, which is b2. So if it is greater than f10, which is our upper bound, or if this is lower than the lower bound, so then we can call it true, else false. So if the value lies between this upper and lower bound, it is not considered as an outlier, and if the value is outside these two values, then it is considered as an outlier. So this formula actually gave us the comparison. So it compare our first observation with the upper bound and lower bound, and then it gave us true or false value. So what you have to do is equal to, then you have to write the function or in the brackets, you choose first value b2, and if it's greater than f10, which is our upper bound, comma, again select your value b2, and if it's greater than f11, which is our lower bound, and then enter. So this value is within this upper and lower bound, that is why it's false. So if you look at this data, we have a value here, and you can see that this is true. So it means that this value is either lower than the lower bound, or it's upper than the greater than the upper bound, that is why it is true. So 99 in this data is a clear outlier. So all those values which result in true are our outliers. So in this data we have only one outlier. We can plot this data to see the we can also plot this data to see clearly whether the outlier is. So we can use a line graph or dot graph. So you can see this data exactly here, it is the outlier. We can also visualize this by using a scatter plot, and we can see that the rest of the data is in quite a linear pattern, but one specific observation is well above the data, which is in our case is the outlier. So the only technical thing is that you have to be very careful here with the estimation of lower bound and upper bound. So with upper bound, what you have to do is you just select your third quartile and then add a value of your interquartile range, but first you have to multiply it by 1.5. So same is the case with the lower bound. In lower bound you have to select your interquartile your first quarter, and then you have to deduct the value of interquartile range, but before deducting you have to multiply it by